All right, so what questions would you like to ask? What you got, Ben?
I still don't really understand standard deviation.
Okay, in terms of what it is, in terms of how to find it, or specifically?
More like what it is and how it relates to the other.
Okay. So standard deviation, it gives us a number.
Mm-hmm.
That number tells us how dispersed the data are. So if we have a set of numbers, are these numbers close together or are they spread out? Okay. So standard deviation gives us a number. That number is used in statistical calculations to find probabilities. It'll be used later to calculate something called confidence intervals and to conduct something called hypothesis testing. So right now when we're calculating the standard deviation, we're simply doing that to capture or calculate a measurement that describes data. It is a number that describes the spread of data. By itself, standard deviation doesn't do a whole lot for us. But if I gave, say, two sets of tests, two classes, let's suppose the two classes were the same. And in one I said, well, the standard deviation was 10, and in the other the standard deviation was 6. What that would tell us, the group with the standard deviation of 6, those scores were closer together than the class where the standard deviation was 10. Does that make sense?
Mm-hmm.
We good? So that's what it is. It's a calculation of a number. Okay?
That shows dispersion, right?
It measures, it's a measure of this dispersion, right, Fernando?
And is that from the mean, or is that just between like each? Like
So the standard
digit
deviation,
that would be on the number.
the calculation uses all the numbers and the mean because it's looking at how the numbers are spread out from the mean. Now, if everyone scored the same grade on the test, everyone got an 82, the standard deviation would be 0 because there would be no spread from the mean. We good? Okay, Ben?
Mm-hmm.
Good so far?
Yep.
So do you want to look at how we calculate the standard deviation?
Yeah, that would probably be pretty.
Okay. Do you understand a little bit better what it is?
Mm-hmm.
Okay. So can I borrow your packet? And let me pick out some grades. For those watching, we're going to pick a set of grades and we'll use those grades to calculate standard deviation by hand.
When you said that on the test, we can, if it's like a big group of data, we can use.
I want you to use both.
Okay.
I want you to use both. And maybe we can try to make that calculator video today. You guys have the same, you know how to do it on your calculator?
No, I was going to ask if
Perfect. So we'll make that an effort. Okay, so let's take 5 test grades. It doesn't matter which 5 I take, but I'll take these. 66, 81, 96, 85, and 90. So these are 5 test grades. We want to calculate the standard deviation for the 5 grades. So what is the first thing I need to do to calculate standard deviation? What's the first thing I need?
create 7 leaf box.
No, don't have to do that.
The 5.
Don't need the 5-number summary. 5-number summary is used for box plot. But I do need the mean. So I have to calculate the mean. And what's the formula that I use to calculate the mean?
You add all the numbers up and divide by how many numbers there are.
Add up all the numbers. What means add up all the numbers?
All the numbers that are present in the data.
I know, but what notation, remember?
Is it it's the big E?
Big E, sigma x, means add up the numbers, divide by how many we have, and that will give us the mean, which I'll symbolize by x bar. All right, guys? So I'll take my calculator, And we'll add the numbers. 66, 81, 96, 85, 90. What do they add up to?
418.
418. So they add up to 418. We're dividing by 5. We divide by 5. What does that give us?
83.6.
83.6. Good. Now what do we do with that mean? What's the next step?
You square it from the deviation.
Not yet. Not yet.
Don't we have to find a standard deviation of every single?
Okay, let's summarize over here the process for standard deviation. So I had this on the board before, so what is standard deviation? Standard deviation is the square root of the sum of the square root of the average. The average of the sum of the squared deviations from the mean. Okay. Is that clear? So I have the mean. What does it mean to find the deviation from the mean? What do I have to do to find the deviation from the mean?
You have to divide everything.
I'm not dividing, just finding the deviation.
See how far everything is from the mean?
Well, I take it one score at a time, so how would I find?
You subtract the score from the mean.
The other way
The
around.
mean from the score.
Score minus mean. So this would be 66 minus 83.6, which would be what? 66 minus 83.6 would give us, what'd you get?
Negative 17.6.
Negative 17.6. And I'm going to want to do what with these? I'm going to want to square them, aren't I?
Yes.
So while I'm here, let's go and hit that square button.
309.76.
309.76, yes sir, good job. Now what do we do?
Do
Take,
that with every single one.
you got it, we do that with every single one. So we take 81, subtract 83.6, what does that give us?
Give me 1 second, Professor. I'm just rewriting the table the way you wrote it.
Okay,
And then the third column is just
the squared,
the square of the
that number, that's right. Because you see, look at the list then. The square root of the average of the sum of the squared deviations from the mean. So check this out. Got the mean, find the deviation of each number, and I square each deviation. So that's what I'm doing here. I'm taking the deviation and I'm squaring it. So what is the second deviation? By how much does 81 deviate?
Negative 2.6.
Negative 2.6. Go ahead and square that. What is that squared deviation? What is that squared deviation?
6.76.
6.76. Okay. The next one, 96 minus 83.6 gives us what?
12.4.
12.4. Square that, what do we get?
153.76.
Beautiful. The next one is 85. We subtract 83.6, what does that give us?
1.4,
Okay, square that.
1.96.
Good job. And then we take 90. We subtract 83.6, what does that give us?
6.4.
6.4.
And squared is 40.96.
40.96. Ben, we good?
Yep.
All right, guys. Now what are we going to do? What does this tell us to do right here?
Add all those.
Add them up. Let's add these columns. Let's add these numbers. Okay? 309.76 plus 6.76, 153.76, 1.96, 40.96. What do you get for the sum?
$513.2.
513.2. Ben, agree?
Yep.
Good. All right. Now we have to do two things. We have to take the average. So remember, because it's a sample, what will we divide by?
By the total number of.
Well, if it's a population, we would divide by the total. It's a sample, we divide by?
One less than the average.
Awesome. Not one less than the average, one less than the total. You're finding the mean. If we're finding the mean, we would normally divide by how many we have. Agreed? But if we're finding the mean of a sample, we divide by one less than how many we have. The reason we do that, that will make that number a little larger, and it will be a better representation for the mean of the population. Is that, or for the standard deviation of the population?
So we do one less than the total of
The numbers.
those.
So how many numbers did we have?
5. So it'd be
5 numbers, we're going to divide by 4.
So that's 128.3.
So we're taking 513.2, we're going to divide by 4, which is 1 less than how many we have. And what did you get, Fernando?
128.3.
All right, so 128.3. And then what do we do with 128.3? What's the last step?
Square root.
Take the square root. So the last step, I take the square root of 128.3. And the square root of 128.3 gives us what? Let's round to 2 decimal places. What do we get?
11.33.
You got it, 11.33, and that's our standard deviation. Is that clear? Fernando? Clear?
Yep.
Questions? So recapping to find standard deviation, we had 5 numbers. We first found the mean. Next, we find the deviation for each score. So we take each score, we subtract the mean. This column gives us the deviations from the mean. Those numbers above the mean have a positive deviation and below have a negative. So we have positives and negatives. That column would add to 0. This column, were we to add this up, would add to 0. And therefore we square each number. We are squaring the deviations. We add those squared deviations. We get 513.2. We divide. Because we're talking about a sample, we divide by 1 less than how many numbers we have. So we take the sum, we divide by 4. And we take the square root, and this gives us a standard deviation of 11.33. Is that okay?
Yes.
Good. We're going to stop this.